Okay, so new video, kind of new concept. I'm going to subtract fractions. All right, so let's take the fraction. Let's take a really easy case. We're going to have 2/3, right? 2/3, and from that I'm going to subtract 1/3. From that I'm going to subtract 1/3. Right? So I start off with 2, and I subtract 1. Right? Well, that's pretty easy. If you have 2/3, you subtract one of them, you're going to end up with one of them. Right? So you're going to end up with 1/3. So again, we see just like when we were adding fractions and they have the same denominator, and when you subtract fractions, they have the same denominator. It's really easy. You keep the denominator the same, and you subtract the numerators. So 2/3 minus 1/3 is 1/3. And as another really easy example, let's do another one just like that. So 7/8 minus 2/8, you know it's going to be 5/8. Right? Denominator stays the same. You subtract the numerators in the order in which they appear. So 7 minus 2 is 5. Okay. All right, let's try a trickier one. Now you have denominators that are different. So let's take, for instance, 3/4 minus 1/3. Okay. So just like I did in the last video, I'm going to use the square candy bars and see how that works. So if I have, this one's going to be 3/4 and this one's going to be 1/3, and I try to make them look the same size. So this is going to be 3/4. So it looks like this. I'm taking divide into 4 equal-sized pieces and shade in 3 of them. This one divide into 3 equal-sized pieces and shade in 1 of them. And now instead of adding, I am subtracting. I'm subtracting the 1/3 from the 3/4. Well, in order to do that, they have to be the same size. So what I do again, just like I did in the last video, is I take this one that's already divided into 4s, and I'm going to divide it into 3 pieces this way. And this one is already divided by 3, I'm going to divide it into 4 pieces this way. And now I have all these pieces are exactly the same size. This one is the same as this one, it's just tilted 90 degrees. Right? It has 12 pieces, it has 12 pieces. They're all the same size. So now I have, my problem becomes I have 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. Subtract from that 4 twelfths. And it becomes really easy, right? Just take 4 away from here. So 1, 2, 3, 4. And I'm left with 5 twelfths. Because we just saw that, right? We saw that in the last few examples. When they have the same denominator, you keep the denominator the same, but you subtract the numerators. 9 minus 4 is 5. Okay. So that's how that works. So really, the same principle applies as when we were adding. You are going to take any two fractions in order to subtract them, right? You are going to take, let's take this. Let's take 1/5. Okay. You're going to do the same kind of steps. You're going to multiply the denominators. 6 times 5 is 30. You're going to cross multiply. It's kind of another way of saying it. You're going to have the 5 times 5. It's going to be 5 times 5 is 25, right? And the cross multiplying going this way, 6 times 1. And then whatever you get, in this case we get 5 times 5 is 25 30ths minus 6 30ths, right? 5 times 5 is 25, 6 times 1 is 6, and then I just multiply. I mean, I'm sorry, I just subtract 25 minus 6, which in this case is 19. All right, that's my answer, 19/30ths. And I could reduce this, but in this case it's already reduced. It's already simplified, you can't go any further. 19's prime. Okay. All right, so subtraction and addition really have the same steps. The only difference is that in one, at the very end here, you're going to add these, and in one you're going to subtract them. So if this were a problem we're adding 5/6 plus 1/5, the only thing I would change is this thing would change into a plus, and you'd end up with 31/30ths. Right? Everything else will stay the same. The first steps are all exactly the same. So you can remember addition and subtraction of fractions, the same thing. You're going to multiply across, multiply diagonal, and then you're done.